Okay, now we're going to start chapter 8. Okay. Chapter 8 is all about crypt analysis. I teach an entire class on it, so I kind of like this chapter. And I want to walk through the first few things they have in the book. Okay, I actually wrote them already. But it would be awesome if you guys would write them, because your program will be somewhat similar to these. I already got in mind what it's going to be, I just haven't written it yet. So I'm not going to tell you what it is yet. Alright, they start talking about, first of all, what crypt analysis is breaking codes. That's, like it says here in the chapter we learned, the topic of crypt analysis is the field of code breaking. Okay? And they get into, they keep mentioning chapter 3, because that's where they first mention it, the codes and other secrets, and they go into this thing called rail fence example. Okay? That's what I want to play with today. Okay, here is rail fence example. Okay, there's a name for it. It begins with T. What's the name for it? Oh, I can't think of the name all of a sudden. Where the heck is it? Can't think of the name. It's begins with T. I'll remember it in a minute. Okay, but in their example here, so if I gave you the code or the cipher text N space OCI space MREIDONTOOWP space NGORW, what's the result? Can anyone just see it? Yeah, new iPod comes out tomorrow. Okay? Yeah, new iPod coming tomorrow, no out. Okay. What they did is they broke it up into 3 different rows. So if you're reading down, it's NEW space IPOD space COMING space TOMORROW. Now we can see that just by looking at it. But we want to write a program to do this. Okay, because that's much easier. You might not think it's easier, but in the long run, it's always easier to write a program. Like on Chapter 7 program, the one y'all are working on. You guys could very easily do all of that by hand, but what if I was to ask for a different county? Like Chelsea's actually writing it to read off the internet, so she's going to get data that's changing every minute. I don't know how often we have earthquakes. Probably every minute there's some form of earthquake here in Oklahoma. So there would be no way you could recalculate data by hand. When I did the index of coincidence in my cryptography course, I tell the students, yeah, you are totally fine to calculate it by hand. And there's 1,000 or 1,400 characters, and people actually went through and counted all the A's by hand and all the B's by hand. But what are the odds you actually do it correctly? Now, if you use the word count function in Word, you're probably pretty good. But the odds are you're going to miss something. So, you're better off to write a program. Now, just because you write a program, does that mean it's going to do it correctly? Okay, there's a description between mine and Cameron's program. We're outputting a different number of earthquakes. I haven't verified which one's correct. It could be his is correct and mine is wrong. It's a very slim chance, but it could be. Okay. See, I haven't looked at his logic. I don't even know what his is doing. I haven't even looked at mine again to make sure mine's correct either. So there's a chance mine's off slightly. Okay? Very small chance. Like minuscule. Like that negative earthquake, no, that's the same kind of thing.
Almost the same chance as you not using it.
Hush. Hush. Luckily back there we don't listen to the peanut gallery. All right.
Chance of the earthquakes in Dewey County?
So they start talking about something called this rail decrypt method. Okay? Rail decrypt, what it's going to do is it reads our cipher text and then we're going to output it. Well, I was nice enough to automatically enter it. And I would really appreciate it if you guys would do it. Now, this actually comes out of section 8.3.3 in the book. I've already typed it in, but I would like you all to type it in. And this is rail decrypt. If you were to go to, let me find it, where's that? 8.3.3, it's actually right there on wherever page this is. This is 270. So if you were to take the code from 270 plus the code from page 265, if you were to take both of them and type them all in, here's what you get. Okay, I'm going to pause for a minute recording so some of you can type this in. Then we're going to walk through it. Okay. Yeah, they're on page 65. This for loop wants to know how we can decrypt ciphertext. Now, ciphertext in this case is this stuff here. It's the N, O, C, I, M, R, E, I, D, so on and so forth, read across. Okay? Because if you were to actually receive that text and didn't know, actually, if you received that and didn't know how many columns down to go, it would be very hard to decrypt that text. Okay? Very, very hard. So what the heck does our program do? Well, let me run it, and you all should get something very similar to that. Okay? So, what it did is it started with one letter and then added a second letter, then added a third letter, and so on and so forth. But if we were to look at this with our eyes, we can instantly see that the third one's correct. Everybody see that? New iPod coming tomorrow. Okay? Pretty simple there. Now, but what does the text do? Okay, I entered our ciphertext right here. I hard-coded that line of text. Actually, you know what? Let's not add another one yet. Okay. Then, so it says for I in range. So the range is starting at 1, go to the length of the ciphertext plus 1. I'm going to try something here. I don't know if this will work. I'm just going to try something here. Okay, yeah, it won't work because it's adding up the number of letters is why. I just want to see what it did. I didn't try that one before. Okay, so it says for, starting at 1, going for the length of the ciphertext. The length of the ciphertext is all this, plus 1. For each one of them, print the results of the call to the method rail decrypt, passing it the ciphertext, and the 1, the 2, the whatever. Okay? So it starts at 1 and goes to however many there are plus 1. So rail decrypt receives the ciphertext and also receives the number of rails. Again, the rails, what they're talking about is this here. It goes down for 3 rows. I don't know why they call it rails. They just happen to call it rails here. Okay. So it receives ciphertext and the number of rails. Okay. What if I was to hard code a 1 in there? Would it work? Let's see what the output does. You're going to get the same thing over and over and over and over and over. So obviously it's not going to give us the correct answer. And you'll notice it's not increasing at all. Okay. So the reason is when we put the I, it actually starts at 1, then goes to 2, then goes to 3, then goes to 4. But that's what we want. We're going to test it with 1 rail, as if there was only 1 line of. So we're testing it as if there was only 1 rail here. In other words, if that was all we received. Then we're going to test it with 2 rails. We're going to test it with these 2. Then we're going to test it with 3 rails, which will be all 3. Okay. We're going to build upon this, by the way. Okay. So we passed that. Then it says the rail length is the length of our ciphertext, and the ciphertext we received here, and it's right here, and it's sent as an argument right there. Okay. All right. Then the solution start off as being blank. Now we want to go for each column in the rail length, because that's going to go down. It says for rail. Now this part here. So what's rail mean? Anybody? Okay, what's this col doing? It's going to be the columns. That's the letters going across. And rail is going to go for the letters going down. Or the rows going down. I probably would have renamed it as rows and columns, but they call it rails. We're going to stick with rails. Okay. Then what they're doing is they're taking 1 letter, then they're adding another letter, and then another letter, so on and so forth. Each time building on a solution, and then we're splitting it on the spaces. Because if you look at our ciphertext, we have spaces in it. Okay? So they're going to do it with, 1 one letter, and then with 2 letters, then with 3 letters, and so on and so forth. Then after our solution is created, then we're going to split it. So if I run it again, so it went with 1 letter, okay? Then it went with 2 letters. And let's look at our ciphertext here for a second, okay? Where is it? Okay, all right. So that's what we end up with. And it's very easy to see what the correct word is. But now we can read this. So how could we make this program better? Anybody? What do you think?
You run it against a dictionary, maybe?
Run it against a dictionary. And that's actually the next step in the book. Because, you don't want to have to look at this manually. Okay? So now if we take the results of this and run it against a dictionary, we can say, hey, we might add something. But before we do that, I want to create something different. Okay? Let's take our ciphertext, and I'm going to get rid of it. Okay? All right. I'm going to create a new ciphertext. And their ciphertext was this right here. It went down. Okay, but I want to do something with 4 rows instead of 3, just to prove that this does work. Okay? But it has to be dictionary words. Well, actually it doesn't have to be initially. Hit the wrong button. So we're going to type it. My name, oops, there's 4, is K-E-N-D-U-I. What? Oh, I missed my. Damn it. I messed it up already. My. That's it. We're starting again. I'm trying to write my name and it's killing me. My N-A. Okay, here we go. Damn it. Don't keep correcting me. It's making me look stupid. It's very hard to write this going sideways. N-A-M-E I-S space K, so far so good, E-N shit space D-E-W-E-Y. That was tough. Thank you. All right. So now I'm going to write my ciphertext. So what's my ciphertext? Anyone know?
My name is
How do I write it? M-A-I-E-E-Y-M-S-N-W space E space E N space K-D-Y. Correct? Is that space? Damn it. So I need 2 spaces here, don't I? Right? Here?
Yeah.
Okay. So we're going to comment this guy out. I've never tried this, so I don't know if this is going to work or not. What do you think? Let's take some bets. Is it going to work?
Should work.
Oh, it's close. Oh, there it is. My name is Ken Dewey. Whew. I think it was harder to write the ciphertext than it was to write the program. But you all see that actually worked. Okay? So, and if you look at this actual ciphertext, if this came through on your network wire and you look at this text, you'd be like, huh? I don't know what that is. But we saw it actually was, my name is Ken Dewey. Alright, so everybody okay with that? Everybody kind of see how that works? Alright, yeah, it actually worked. Thank God it worked. Alright, so let's move on to the next part. Okay, the next section of the book, actually that's what we walk through, and it says checking our work with a dictionary. Now, the first one, they talk about downloading a word list.txt. Okay? That's the tough part, getting one. And actually getting a good one. So I'm going to upload one on D2L, which you will be using. I'm going to upload it right now so y'all can have it. Because I got one. I didn't want you guys to have to go find one. D2L has been sluggish today. I do not know for sure if this is going to be used at all in your program, but I'm going to put it up underneath Chapter 8. So if you want it, you can download it. It's called wordlist.txt. Okay, there it is. The file is now up there. What word list is, imagine this, it's a list of words. Look at that, starting at A. What I did is I took a word list I found on the internet, and the one in the book they're talking about has 40,000 entries. This has like 105,000 entries, but it's the shortest one I could find. So, and I didn't feel like searching for too long. So if you want to download that to walk through this demo, you can. It is up there. So it's on D2L. So they start talking about the way to make our program better would be to compare it against a dictionary list. Okay? And possibly find the one that's decent. Their example, they're using 41,000 English words, but they don't tell us where to get it from. Imagine that. So like I said, I found one, but it's considerably longer. Okay? Now, here is the next demo I would like you guys to do. Can y'all download that file? Can y'all download that? Just save it somewhere, wherever you're writing this stuff at, so we can use it here real quick. So download word list. It's a text file. And then we are going to work on this program, which is the text out of the book. I want you to type this in. Okay? I'm going to show you what it does. It does that. Pretty handy. So that's the way you tell if it works. It does that, which is not much. But go ahead and type that in. Download the word list. Type that in. Then we're going to talk about what this does. I'm going to pause for the moment. Okay, so now that most of us have this typed in, again, if we run this, you really shouldn't get anything. It's about all you should get. Can someone tell me why that's what we're getting and nothing else? Anyone know why? Why? You're not even in this class. Shut up. Anyone else? Come on, Sam, I am. Why is it an output? Because I didn't tell it to output anything. All right. So I want to change this so I can see if it's actually working, because I really hate programs that do nothing. So how can I change it? Well, first of all, I want to make sure we're opening the right file. So right here, I'm going to say print dname with parentheses. So what should it print out? Should just say wordlist.txt. That's what it should do. Oh, okay. So at least we know we're passing the file name wordlist.txt to our method, and that part's working. Okay. Step 1 done. Okay. Now, for here, we're saying for line in my file. My file is the file we just opened. So I want to know what the heck are we reading in. So now I'm going to say print line. So what will that do? It should print out on the screen each line we read from the file. Ready for it? It's going to take a while. Okay, so is it working? I would say yes. It is reading in each line and printing it. And there's 100 and something thousand, so you really need to hit Control-C, or you'll be here a long time. So it didn't error out just because I hit Control-C. Now, when I was testing mine, you'll see I actually I made a partial file that only had a few entries in it so I could test it. Okay. But obviously, if you guys just copy my code, you're good. So, did anyone put that print line? Did it work? Yes, some of you did that? And you had to do Control-C to stop it? Okay. So, this next line, you'll see I got a comment after it. What the heck does the above line do? Any takers on that? Okay, what's my dict? Dict. With a T. Dict. I really need to stop using the words he uses in the book. All right, so what is that file? What is it? Someone said something. So what is that? It's a dictionary. Hence, I'm changing mine real quick. I'm tired of saying that word. Okay, let me make sure it still runs. Yes, we're still good. So I would hate to someone say, he's using a bad word in class. So there. So
So how you, what is the stop again? I'm sorry.
Control C.
Alright, mine is still on.
Okay, let me look. Did it stop? Okay. Yeah, it will go for a very long time. All right. Now, what this says is my dictionary, which we know is the dictionary. Line. So what's line?
That was the words in the file.
It was the words in the file, that thing that kept going on the screen forever over there with Ben. So this is my dictionary. We're creating a dictionary based on line. Here's the big question. What the heck is that? No, it doesn't tell you in the book. It really doesn't even tell you on the internet. I looked. What it is saying is, take each line. Now, we saw something similar to that before. Remember when we were talking in range and stuff like that? What this is saying is take each line all the way to the very end, minus 1. Okay? Go all the way to the very end, minus 1. Does anyone know why? It's not a space, but it's very close. There's actually a /n at the end of each line, which is a carriage return. Because this is a Unix encoded file. So I think, actually, let me open it up with Notepad. I don't know, I probably still won't be able to see it. No, I still can't see it. But in Word, that's right, in Word we could see it. But wait, TextPad, how do you show the view? View, there's something we could see it in here. I don't know where it is. Wait, there it is, there it is. You can actually see that little thing there at the end of each line. That is the carriage return. Okay? And what I did was I clicked on this guy here. And you can also do that, but it's not going to affect anything in here because there are no word wraps. So what it is there's A and then there's a /n. And let me try something. Search. Don't do this. Okay, don't do this. I'm telling you to find the carriage returns, replace it with an A. No, it didn't work. Okay, hold on. Match case. I wasn't sure if it was going to work or not.
You'd have to copy the active story to turn
Yeah, that'd be too much work. That'd be way too much work. Okay, but there is a carriage return at the end of each line. So what that line is telling it to do is create a dictionary, add each line to it, but this says -1 character. So in other words, get all but the last character because we don't want that /n in there. Okay. Now this whole true part. Remember, a dictionary usually has a key and a value. Remember that? Those of you who are working on Chapter 7 still, has a key and a value. So we're actually storing keys only. We don't want a value. So the question comes up, why, if we're only using the keys, why not just use a list? Does anyone read ahead of the book and know why? Because they're saying a dictionary is actually, what, I think 26,000 or 2,600 times faster than if you did it with a list. Might not sound like much, but our file's 100 some odd thousand lines. But I've worked with files that were millions of lines. And I could see it being a lot quicker. So this is really just creating us a dictionary with all but the last character of each key and then a true. That's it. Now, let's see that it actually did something. I'm going to go down here and I want to print out, I want to print out my dictionary just to see what the heck we're getting. And we should get a forgot. This is the big file, isn't it? All right. Stop. Please. Stop. Close file. All right. Can't do that. So I happen to have, you don't do this on yours, I'm just going to show you. I have a file called wordless partial. Just for this example. Now I'm going to send it wordless partial. Now I'm going to do it again, but this time with a partial word list. That's what you get. Okay? Don't do it on yours. I just want to, because I only went through a couple hundred of them, then I stopped it. You'll see we have all the keys, which are the wordless entries, then we just have true. Because that's all we need. Okay, we could have created a list, but we really didn't need one. Okay? Alright. So let me go back, get rid of this. Yeah, because I find when you try to print 109,000, no, it's not good. Your program kind of has a hard time with that. Alright. So if I run this, and it's actually only the printing that takes so long, because you see, we already ran the entire thing. It's just the fact of compiling the list and then printing the list out that takes the time. Compiling's not an issue. So everybody got theirs to work? Alright. So now, the next section in the book. Okay, so we got our word list, just like they typed it there. Okay. They talk about brute force. Okay. What brute force is try everything. Okay. It's kind of funny. I was giving Professor Stokely a hard time yesterday and this morning because he had to change his password yesterday. I'm assuming where y'all work, you have to change your passwords every now and then. I think ours is set to 120 days. He changed his yesterday. Then right after he changed it, he came down to talk to me. Totally forgot what he changed it to. So he locked his account out, and he was actually locked out until this morning. I've done the same thing. So what I normally do now is whenever I change it, I write on a sticky note, put it in my pocket for a couple days. Because I've done so many password changes in my life that now I'm using bizarre passwords that you can't remember half the time. So, yeah, exactly. All right. So what brute force is try every combination? But like in our Windows domain here, row state, you get 3 chances. If you do it 3 times in 5 minutes, you're locked out. Now, if you'd only done 2 times, waited 15 minutes, then 2 times, waited 15 minutes, it would have been fine because the domain will reset at that point. But since you did 3 times, that's our threshold, so they'll lock them out. So what they're doing here is they want to make something called rail break. Okay? All right. Now, I was nice enough to type that in as well. And it's right here. Now, it is very similar to what you guys already have. So if you want to take your first 2 programs, the decrypt and the create dictionary, go ahead and put them in the same file. Now I'm going to rename mine to solve that problem. Alright, and then, so you get your first 2 programs you wrote inside there. You have to modify a little bit, but not very much to get it to work. So just the first 2 you wrote, the first 2 methods, and then add rail break, and also add this bottom stuff. Now the bottom stuff is changed slightly. Okay? The bottom stuff you had to change the number of arguments, and you're also going to need to change the other, but that's a little bit. So if you want to type that in, it's directly out of the book. Let me tell you what page it's on in case you want to type it out of the book. It's on this page, which is 268. There it is. So I'm going to pause this and let you guys type this in a little bit. All right, I know not everybody's got it working, but some of you do. So when you run it, what you should get is new iPad coming tomorrow. iPod, same thing. And by the way, that word dictionary, I actually had to edit it because I could not find one that included the word iPod. So I actually had to edit and add iPod to that dictionary.
Did you add your name into the dictionary?
No.
Because it's in there.
Oh, it is? Mm-hmm. Oh, wow. No, I did not add my name in there. Okay, so what this is doing, we still have our cipher text, but instead of rail decrypt, we change it to rail break, and we pass it our cipher text. So receive our type for cipher text, we open our file right here, then we check the length, and we set max good so far. In other words, how many valid entries have we found so far? And I did note that if you don't use the right word list, it returns no words found in the dictionary, because I had an issue with that. I mistyped it. So then we're going through our cipher text, and we're running that decrypt, the same decrypt we had before. We're running the decrypt and returning basically a list of those. Then for W and words, let's see what actually gets returned here. So I'm going to print words. I would like to see what these calls are doing. So when I run this now, it should tell me what's returned from that. That's exactly what we got the first time we ran it. Look familiar? That very first call we made. So that's what we got there. So we know this part's working. So we're going through and we're getting that. So that's good. All right. Then for W and words, so what the heck is that doing? Print W. You can always do this to see what your program's doing. And those are each of the elements. Remember, return them as a list. So now we're looking at each one separately so we know they're working. Because if you don't do stuff like this, you can have a hard time figuring out problems. And when you guys send me code with problems, I do the same thing to your code. I'm always adding stuff like this to say, what the heck is it doing? Because, it could be something basic. Okay? So now in here we're doing for W in word dict with the dictionary. Okay, so here we could do the same thing. Print W. And you notice I'm removing every time I do it, I'm removing it. And there's all the different letters. Okay. So you now notice we actually only have 3 good words. New 4. New iPod coming tomorrow. There's all the other letters separately. So that was printing out the ones that match. And for each one that matches, we're incrementing good count, and that's where we're going to come up with 4. Now let me get rid of that. Okay. Now if good count is max, then max good so far. In other words, we're keeping track of how many good ones we found. Now I wanted to print, I think this is where I did it before. Let's see if that prints out what I want to see. No, that's not the one I want to see. We're about out of time, but I can't remember exactly where I added the line, but I actually did it where I could see exactly which word and how many counts it had. But we don't have any time since actually class ends right now. But if you haven't got this to work, get it to work. You won't need this for your next program, but you'll need a portion of it. It'll be similar. So, because if you actually look on your thing here, if you continue on just a little bit farther down, which we haven't got to yet, they're actually going to be doing something with frequency analysis. We will be doing this. So we're getting to this point. We just haven't got there yet today. Okay? So I asked that the stuff we've been working on today, get it to work. When it runs, you should be able to hit F5 and you should get that. Okay? Just so you can get it to work, because you will need a portion of this for your next program. Okay? We're done for today since we are out of class time.